This is a video for learning how to factor cancel to simplify rational expressions. We are going to be graphing more complex rational expressions, things with x squareds in them. Even something as complicated as this. And so we need to learn how to simplify them before we can continue to work with them. So what we're doing is we're learning how to simplify these types of rational expressions. And the general rule of thumb is that you cannot cancel terms, you can only cancel factors. So when I look at this one right here, these are terms. It might be tempting to cancel these x squareds, but these x squareds are terms because they're being added to 7 and added to 8. So I have 4 terms here. And since these are terms, I cannot cancel those out. Okay, so I cannot cancel the x squareds because they're terms. You cancel the x squared. If you cancel x squared, that would just leave 7/8. That is not an equivalent statement. This is actually a kitten killing moment from our signs on the wall. You cannot cancel terms or a kitten dies. Very grim, yes, I know. But, so don't cancel terms. So what we're looking at is trying to cancel factors. Now I can see these are not terms, these are factors because they're being multiplied. X times the quantity of x minus 4. 5 times x times the quantity of x minus 4. They're separated because they're now factored out. They're separated by multiplication. So I can cancel x minus 4, and I can cancel the x's. And I would be left with 1 over 5, because if I cancel x minus 4 out, and I cancel x out, I'd be left with just an unseen 1 over 5. And I am allowed to cancel those because they are factors, not terms. So when I look here, I can't cancel x with x. I can't cancel the 16 and the 4 because these are individual terms. And because these are terms, I can't cancel them. I have to factor them, and then I can cancel them. So we're going to start by factoring the numerator. If I factor this numerator using the conjugate rule, x squared minus 16 becomes x plus 4, x minus 4. These x minus 4s are factors. They can cancel out this quantity of x minus 4 and this quantity. Because if you have something divided by itself, it's just 1. So because they're the same on top and bottom, I can cancel x minus 4 with x minus 4, which leaves me just x plus 4. And then we're going to take a look at example 2. I have another numerator that can be factored. Again, I can't cancel these x's or these 3's. Those are terms, but I can cancel once I factor. So if I factor this numerator, x squared is x and x. Factors of 3 would be 3 and 1. Now does that work to make plus 2 in the middle? Yeah, if I multiply this out, I would get 3x minus 1x. It would give me 2x in the middle. So now that I've factored the numerator, I have x plus 3 and x plus 3. Those would cancel on top and bottom. They're the exact same factor. One on top, one on bottom, they cancel. And it leaves me with x minus 1 as my final answer. Let's do another one with a conjugate and a GCF. Now in this one, I'm going to have to factor both the numerator and the denominator. So we're going to start by taking a GCF out of the numerator. I see that both of these terms have an x in it. So I'm going to take out the common factor of x, which would take an x out of x squared, leave me with x. Take an x out of 5x, leaves me with 5. So I have x times x minus 5. Now in the denominator, I have a conjugate rule. It's backwards, but it's a conjugate rule. These are perfect squares, so I would have 5 plus x and 5 minus x. I have to keep the same order. You know, you can't subtract in a different order and have the same answer. The order matters with subtraction. So I need to leave this as 5 plus x, 5 minus x. Now, these aren't quite the same, x minus 5 and 5 minus x. So we're going to use a trick that we learned earlier this year. If I take a negative 1 out of this 5 minus x, take a negative 1 out like a GCF, then I can reverse the order and make x minus 5. So if I take a negative 1 out of 5 minus x, it makes negative 1 times x minus 5. Now I can cancel these two. So what I'm left with is x over x plus 5 times negative 1, because the x minus 5 is canceled. And I'm going to take that negative 1 and apply it to the numerator. So I'll write it as negative x over x plus 5 as the final answer. Okay? So again, just in general, if you have the same thing with a minus sign, but it's not in the right order, take a negative 1 out of one of those factors, and you can switch it around and make them the same so that they can cancel. All right, next example. I'm doing several examples because I know some of you struggle with factoring. The numerator, what I'm looking at here is, okay, I have to factor this out. So I'm going to start by taking factors of 2x squared, which would be 2x times x. Then let's go to the last term, 6. Factors of 6 are 3 and 2. Now how do I know this combination works? Well, we have to check it. And I'll check that here on paper. What I have is 2x plus 3 and x plus 2. So I have 2x squared broken up. I have 6 broken up into 3 and 2. And if I check that, and I multiplied it out, 2x times x is 2x squared. 2x times 2 is 4x. 3 times x is 3x. 3 times 2 is 6. So I have 2x squared and 6 like I wanted. In the middle I end up with 7x, which is exactly what we needed for the middle term, is 7x. Alright, now this denominator is a little easier factoring. X squared would be x times x. Factors of 6 would be 3 and 2, but I need to get negative 1, so it has to be x minus 3 and x plus 2 to add up to negative 1 in the middle. And so I have x plus 2's canceling. Both of these had factors of x plus 2, so that shared factor cancels out. And it leaves me with 2x plus 3 over x minus 3 as the final answer. Okay? Now, we're going to take a look at this one. We have some GCF to do here. GCF actually will make this a lot easier. Always look for a GCF first. So on this one, I'm taking the numerator. This numerator has a GCF of 2. And then factors out into m plus 3 and m minus 1. This denominator has a GCF of 4, and so I would factor that into 4 and m plus 3 and m plus 1. And they skip a couple steps there, so I'm going to go through this quickly on here. What I have is 2m squared plus 4m plus 6 over 4m squared plus 16m plus 12. So again, I'm just going to take a look at GCF here would be 2. So I'm going to take a 2 out. When I take 2 out of each term, I'm left with 1, 2, and 3. Now, when I take a GCF out of here, I can take a 4 out of this. So if I take a 4 out, I'm left with 1. 16 divided by 4 is 4. 12 divided by 4 is 3. But again, I can factor both of these. So I'm going to have 2, and I'm going to factor this into m and m. Factors of 3 are 3 and 1. And this is going to factor into m plus 3 and m minus 1. Oh, I just realized I wrote the wrong sign here. This was actually a minus sign in these problems. So that minus sign allows me to have plus and minus. I wrote the sign wrong originally. Okay, so then we're going to come down here. I have 4. And I'm going to factor this remaining one into m and m. Factors of 3 are 3 and 1. To get 4, I would have both plus. So 3 plus 1 adds up to 4. 3 times 1 makes 3. And so I have m plus 3 canceling. But I can also reduce this. 2 fourths reduces to 1 over 2. So what I have in the numerator, I have a 1. I don't need to write that. I have m minus 1 in the numerator. Down below I have a 2, and an m plus 1. And that would make my final answer. Alright, so you have quite a few practice problems. Make sure you get it in practice. You need to practice factoring to get it down. So you have lots of practice to do. Some of them are easy, some of them get a little tougher. I gave you some hints along the way. So get in there and do that practice. It's really important, or you won't be able to do what we do for the next week leading up to next week's test. So make sure you put the work in on this one.